So in the last video, we were measuring angles using protractors, etc., and trying to figure out what was going on. I hope you came to the conclusion that the relationship seemed to be that the inscribed angle was smaller than the arc and always half. So we have these three, what these pictures are, case 1, 2, and 3, are the pictures we did with the construction marks, all erased. So the same markings, except for that I've erased all the construction nonsense. So what is the difference between each case? So what's going on in case 1, case 2, and case 3? And we will start with case 1. The center of the circle is on one of the sides of the triangle is on the diameter, and that's how that one's different. The center here is in the inside of the triangle, and this third one, the center is on the outside of the triangle. And so that's the main difference. It is important to look at these three because it's the way the circle came to be and all those things. Make a conjecture about what we did yesterday about how the measure of the arc is related to this inscribed angle. And I just said it at the start of the video, so if you want to back it up, you can. So pause the video and make your conjecture. So I hope that you came up with the inscribed angle is half of the measure of the intercepted arc, or the intercepted arc is double that of the inscribed angle, or two inscribed angles make the intercepted arc, whatever it happens to be. Basically, angle A is half of angle B. So if this is 50, that's 25. So it's half. That's the relationship. What is the difference? We did that. Prove your conjecture in the three cases above. So how would we prove it is the hard part. So the question is, we've got our three different cases. How do we prove it? We're going to focus on one angle. And so you'll notice in each picture that in this one, angle A is marked darker. In this one, angle M is marked darker. In this one, angle Q is marked darker. We're going to use that. We have this angle here being the inscribed angle. We really need to name our inside point. We're going to call this one O, this one Q, but you can't call it Q. This one P, and W for no reason at all. And so we're going to talk about those. And how do we do it? Well, when it's on the circle, this one's easy. Because when it's on the circle, this is, we can use this arc, that's 180, and this angle here, the central angle, the arc is 180, the whole circle is 360. That's a little tricky, but true. And so that's kind of the idea here. So think about what you can do. You can also just measure your angles again and should demonstrate that they're the same. And that's what we're dealing with, is what is happening here. So let's think about these proofs a little bit for a minute. I'm going to pause it while I think. I'm going to go ahead and demonstrate what you're going to do with case 2. So I'm going to grab a picture of it so I can make the rest of this kind of disappear. And so prove with these three different pieces above. Remember, when we're doing our proof, it has to work for everything. And so we can't just put one, we have to do it for all of them. What I'm going to do is I'm going to put angle M. And what I know about angle M, O, and N, so, and that's because of the angle sum theorem. And so, angles, that's the angle in a triangle. I'm going to type instead of try to write this. Let's get smaller so it's more font there. The angle in a triangle add up to 180. The measure the three intersected arcs form a circle and they're add up to 360 degrees. So since the relationship is half, that relationship holds true for that's not the greatest proof, and I think for most of us, the measuring is better. This is how you prove it: is because we know that that's at 20, and this, these arcs here at 360, that half relation is kind of obvious. It's completely obvious. It's not completely obvious. I want you to think about it. And let's get into what that means for an example. So you have these 5 problems to do for your homework, and then the guide, which you did before. So the goal was assigned yesterday. So we're going to do the set here, and what we need to do is figure out what's happening here. So we have a circle. We know the central angle, and it's asking us for component information. So it wants to know this length of this arc. It wants to know the measure of angle OLN, so this angle here. And it wants this arc as well. I'm going to put it in red. That is terrible, but putting it in red. And so that's what we're going to figure out is those 3 things. We're going to start with the blue arc. Since the central angle is 110, this has to also be 110. We're going to go to this angle next. We have this arc is 65 degrees. So that angle has to be half of 65 degrees. So 32 and a half is that one. And then OL, we're going to take these two and subtract from 360. So 360 minus 110 and minus 65, which gives me 295 minus 110 is 185. And so there you go. And so that's the idea of what you're going to do with homework. Good luck, and I'll see you soon.